So now that we got the rotating assembly in it, it's time to start looking at the camshaft and all the timing gears and chain. But before we can actually put those in, we need to put the front plate on the engine. Now I have a theory regarding the front plate and the gaskets and stuff. See, I really like the pan gaskets, and it seems to be the most popular gaskets. All the big engine builders and everybody really like these gaskets because they're nice and thick, and they're good quality gaskets. The theory I have regarding that, it would be nice to actually hear from some of those bigger engine builders who their whole business is just building engines versus someone like me who just builds them, a couple a year maybe. But the gasket thickness itself, I think, matters because you got a gasket here, then you have the front plate, then you have the thrust plate. Now the thrust plate, not only the thickness of this is setting the actual thrust clearance of the camshaft, but it's positioned, but with it bolted to the front of that plate, it's also positioning the cam within the engine. So the thicker that gasket is, the further it's going to push this plate out, and the further forward the cam is going to be within the engine block. The thinner it is, the further back it's going to be within the engine block. Now the position of the lifters in relation to the cam is an engineered thing. They're not exactly perfectly in line with the camshaft lobes. They're slightly offset to promote them to spin. Now, I do know that in the case of these MGB engines, I've heard, at least, that the position of the lifter bores isn't necessarily the most accurate in the world. And even between each bore within the motor, can be some variances, especially in later production where the tooling was getting wore out. If you look at the original gaskets, would have been paper gasket like this. Now this isn't a front plate gasket, but it's representative. It's about 10 thousandths thick. Pan gasket here, about 40 thousandths thick. That's 30 thousandths of a difference, which means the cam is going to be sitting forward in the block basically a 32nd of an inch more than it would be with the thinner factory gasket. How much does that actually matter? I'm not 100% sure, especially with the variances that are known to be within the lifter bores. But my theory is the closer to where it's supposed to be, the better off you are. Now I do have one other reason besides that for wanting to stick the thinner gasket in here, and we'll get to that later. The fact that the lifters have to spin in their bores is an important thing, which is why I hone the lifter bores if they're tight. Because if they're not spinning in their bores, you can wipe a cam out, especially with a brand new engine, and they don't spin very well at anything below, say, 1800 RPMs, which is why you should never, with a brand new engine, just start it up and let it idle. You got to keep it above an RPM that will promote good spinning of the lifters. Most people say 1800 RPM, some say 15. Now APT, who I got my cam from, suggests keeping about 2500 to 3000 RPMs. Now that can be very nerve-wracking because as soon as you hit that key, you're just like, you're going to bring that RPMs up. Did I tighten everything? Am I sure I torqued every bolt? I don't want to throw a rod. And it really freaks out my customers if they're actually around for an initial startup, because I usually keep it just between 2 and 3. So now we have to start out by putting the front plate on. Now, one of the things I really like about my engine stand is I can just do that. So when I go to put the cam in, I'm not trying to balance the cam and trying to hold on to the very end of it and try to get it in there without nicking up any of the bearings or the lobes of the cam. I can just take the cam and just drop it in there nice and smooth and no problems. And it also makes it nice and easy to sit and do this and line everything up and make sure everything's looking nice. Now I have one other additional little wrinkle in my case, because I have this aluminum front plate that I made. Now this plate is about 10 thousandths thinner than the original factory plate, because aluminum isn't available in all the same sizes that steel is, and that's the closest I could come in the right aluminum from where I was getting it from. The gasket that I'm using, which is one I ordered separately from the kit, actually measures 15 thousandths roughly, which means I'll be within 5 thousandths on cam position. So I think I'm going to be pretty good on that. Now, in case any of you are wondering, I do not put my gaskets on dry. I do prefer to put a little light smear of a quality gasket sealer on there. Now, when I say quality gasket sealer, I don't mean blue RTV. I know a lot of people really like the Hylamar in the British car world, and a lot of old school guys like to use Indian head, but I tend to use like the ultra black or what they call, or the mega black RTV. I really like the Permatex products, but I switched to using the mega black from the, was it Versachem, I think it is, because ever since Permatex went to the silver caps on the tubes, the caps are brittle and they break way too easy, and I never get through a tube without the cap breaking off and then the whole tube dries up. But I didn't want to bore you guys with me just smearing gasket sealer, so I've already got the gasket on there, and what I do is I like to put all the bolts in. Now I got some short bolts in here where the timing cover goes. And I got all the bolts in for the cam plate and the tensioner and everything, because I want to make sure every bolt hole is lining up, and then I tighten it down. And these are temporary bolts right now, and they're going to stay in there for now because it's going to be a few weeks before we actually put the head on this thing and get the timing cover on, because all of that's on my other engine, which is currently in the car. Because when I threw that temporary engine together, I didn't have any other timing covers with a top timing tab that was loose. So I stuck the one from this motor on that. So at any rate, the cam that I bought for this is an APT VP12. This is about as much cam as you'd ever want to run on the street. For most people, a VP11 is probably plenty for the street, or even the 10 is good cam. A stock cam would be a 252 duration, 360 lift. And here's the spec sheet, which is actually for the 10, 11, and 12. But this is 286 duration, 401 lift. So it's going to be relatively rowdy sounding. But these cams are not cheap, but they're good quality blanks, properly hardened. A guy knows what he's doing. David Anton, I think his name is. He had worked with David Vizard years ago, so he knows what he's doing. And this is some pretty good stuff. But, like I said, not exactly cheap. So before you actually put your cam in, you need to lubricate it. And I don't mean with oil. You need to use a good cam break-in lube on it. In this case, they give me a bit of cam lube with it, so I'm using what they provided. And you don't really want to use like the Ultra Slick on your cam because it's too thin. You need something a little thicker body. What I use a lot of times, if I know I'm going to be finishing putting it together and it's going to go right into the car that day or no later than the next day, I'll just use like the Kent Cam's cam lube, which looks very much like the Ultra Slick, but it's a little heavier bodied, so it sticks to the cam a little better. But if you're not, it's going to be a little while, more than a day, you know, like a week or whatever. You need something much heavier bodied. Like this stuff is very much like a grease, very thick. So you want to use something much thicker that's going to stay in place. Because if you use something like this, it'll just end up in the oil pan by the time you get it started and won't do you much good. Now I will use this on the journals because it's just fine for that. And it's also a good idea to go ahead and test fit the cam gear onto the end of the cam before you stick it in, especially if you bought a cam that didn't come with the keyway already in place like this one did, because you want to make sure you got it fully seated and that the cam gear will actually go on. So in my case, I can literally just take the cam and just drop it in like that. That makes it really nice. Oops. Get that in there right. Then we can bolt this thing in there. And then I can put the cam gear on it. We can check the thrust and move on to timing chain. So once you get that bolt on there, you can snug that down to where it doesn't move anymore. It's relatively tight. You don't have to torque it at this point. And you can take a feeler gauge, you get in behind here and measure for the thrust. Now I already know mine's good because this is the same gear, same thrust plate and everything that I was using before, and I had made sure that it was right before, but the specs are in the book. Now you can actually, with a really good dial, calipers or micrometers, measure the thickness of that plate, and then there's a step on the back side of that, which I'll show you later once I take this back off to do the actual timing chain. You can measure the thickness, the amount of step there is in there, and you can figure it out that way how much thrust you should have before you bolt it together. I have had, usually when I take a rubber bumper car and swap it to the dual chain, I've had them just lock up, be too tight, not have any thrust at all. Then get a new thrust plate or thin that one out for the flat plate. Apparently, I don't know for sure, but apparently factory had two different thicknesses of thrust plate maybe, but when you go buy new ones today, they give you one thickness. But I've had them lock up before where there was no clearance whatsoever. And I actually made myself a jig by taking a old cam, cutting the end of it off. I could chuck that in the lathe and then put the gear on backwards, and I had a nut that's been turned down a little bit, and then I could actually dress that up and get my clearance that I'm looking for. So when I went to start putting all this together, I could not find my crank gear anywhere. It had been 2 years since I tore this apart, and after moving and everything else, I don't know what happened to it. So I ended up buying a new gear for it. And I went ahead and upgraded to the new, what Moss lists as their heavy duty timing chain. Thought I'd go ahead and do something a little better than the cheapie. So I got that, but I am reusing the original cam gear from my old engine because it doesn't really have any real wear on it to speak of, and this has been modified. First of all, I do know that the clearances on the back, this is the step I was talking about here. You can measure the thickness from here to there and the plate and figure out how much thrust you have. But this has also been lightened. It's been turned a little bit on the inside and the outside to get rid of a little bit of weight. It's one of my things. When you're autocrossing and you lose a trophy position by, you know, just like what, 12 or 15 thousandths of a second, you start thinking about little things like this to say, well, what could I have done to maybe gone a little bit faster and gotten that trophy? Now, they have dots in the timing chain, but if you really want to do this right, you don't just put it on here, line up the dots, and call it a day. You actually want to check the cam timing and make sure that it's correct. There was one time I had a car where it had been a while since I'd seen anything that was that far off. But there's a thing called stacked tolerances. Each one of these parts could be, you know, half degree, or even more off. And if you have more than one part that's off, and all go in the same direction, you could be pretty far off even lining up the dots. But I had one time where it was just a rubber bumper car where the guy was just wanting to stab a cam in it and go. He wasn't worried about, you know, performance or anything, and we just went boop, took it down the road, and it was a dog. It was slow, wouldn't get out of its own way. Way worse than normal. And went ahead and pulled it back apart, went through all the cam timing, which is much harder to do in the car because we had swapped the cam in the car with the head on and everything that it is on an engine stand and with the head off. Found that thing was like 8 degrees off. Put 8 or 9 degrees. Put a offset keyway in it, and that thing ended up being one of the best running rubber bumper cars I'd ever play with. And it was just, as far as I know, stock bottom end, and it even had a Weber on it, downdraft Weber, which never does these cars any favors as far as performance, despite what some people on the internet say. And that's mainly due to the manifold that it's on. The manifold's not that great, but that's a whole nother video maybe. First of all, since this is a new gear, got to test fit this thing on here, make sure it'll actually go on, which I'm going to play with that for a minute here. Make sure it slides on and off nice and smooth, and then we'll get back to it. So now we're on to the second reason why I say I don't like using the thicker gasket behind here. If the cam is pushed forward 30 thousandths of an inch, then it's no longer going to line up to the crank gear unless you take and add 30 thousandths worth of shims to the back side of that and bringing it out further. But you check it by putting a straight edge across there and then using a feeler gauge on either side, whether it's this side or this side, depending on which one's higher, to see what the difference is. And you don't want to see a large difference. A few thousandths of an inch is no big deal, but if you're seeing 10, 15, 20, 30 thousandths difference, then it's going to be more wear on the gears and the chain itself. So I'm not going to go through the whole process on this video of actually degreeing the cam end, but I will say that it does not take like a lot of expensive tools or anything to do this. All you really need is just a timing wheel and a dial indicator. And it doesn't have to be a really expensive dial indicator either. This is just a Harbor Freighter. And then you can just take a piece of wire, stiff wire, to use as a pointer. But I will say, what I always do, because I don't build enough engines and rather than committing it all to memory and just to make sure I'm remembering correctly, I always have my Peter Burgess book here of how to power tune the MGB 4-cylinder engine while I'm doing it. This is good reference material to make sure that I don't forget anything. And it also is a good reference, like if you're working with a factory cam, it's giving you all the specs here, telling you that it's 106 degrees. And also it tells you in here, like each one of these teeth on the cam gear is 18 degrees. So if you go and check it and you're like 20 degrees off or 16 or something like that, then you know you need to move that one tooth. And then from there, look at the offset keyways to get you where you want to be. So I ran through the cam timing. I always do it at least twice, make sure I'm getting consistent numbers. And I got lucky on this one. This cam is supposed to be timed to between 102 and 103 degrees. And I'm just right shy, just barely shy of 102. So through all that process, I never did put the timing chain gasket on, or the lock tabs, or the lock tab on the cam, because if you have to take all that stuff apart, it's no sense putting it on. So now that we know we got what we want, we can put the lock tab there, take the tensioner off, put the gasket behind it, lock tabs, getting all that all buttoned down and ready for the timing cover. Now, one thing you do not want to forget is you don't want to forget to put this little plug in the timing chain tensioner, because if you don't, the oil will just flow right out of there and won't build any pressure, because it actually uses oil pressure to actually tighten the timing chain properly. Now, I haven't released it yet, so I'm not locking it down yet. But there's a spring in there. You can release the tension off of it, get the tension on it, and then you put the plug in there. I usually bend this up over the housing and this over the bolt.